All right, this is morning review, chapter 4, test, morning review, continued, and this is non-calculator portion. So number 5, find the definite integral of x times the square root of 16 minus x squared from square root of 7 to 0. Okay. So we first want to just try to evaluate the integral, and then we can deal with the lower and upper bounds. We first see, can we simply resort to using power rule? And we can't just distribute the x through because 16 minus x squared is quantity raised to the 1/2. So we have to take care of that exponent first, which means we have to go through u substitution. So our u value is 16 minus x squared. All right. And we can find the derivative. So the derivative of u becomes du with respect to x. The derivative of u with respect to x is written as du over dx. So the derivative of 16 goes to 0. Negative x squared becomes negative 2x. We cross multiply, solve for dx. Dx is simply equal to du over negative 2x. So we make our substitution into the original equation. We're going to replace 16 minus x squared with u. The x does not get replaced initially. Now the square root will turn into rational exponent raised to the 1/2, which we have here. And then dx gets replaced with du over negative 2x. Okay. We want to make sure that all the x's cancel out, and they do. These two x's cancel out. So now we also have to make sure that we don't lose this coefficient that's still part of the problem. So we pull this out in front as negative 1/2, and we can just isolate the portion that we're going to apply the integral rule for. So u to the 1/2, we can simply use power rule, which becomes u to the 3/2 over 3/2, right? We're just adding 1 to that original exponent. 1/2 plus 1 gives us 3/2. We divide it by that this new exponent. So we flip this reciprocal. So 3/2 becomes 2/3, and the 2's cancel out. We're left with negative 1/3 u to the 3/2. So this is a definite integral problem that where we're applying u substitution method. So because our integrand is in terms of u, we also need to make sure that our bounds are also in terms of the same variable that we're evaluating. So right now, square root of 7 and 0 are in terms of x, but what we just found, the integral is in terms of u, so we have to make a conversion. Okay, so we use this assignment for u to help us make that conversion. So plug the lower bound, square root of 7, in for x. So we get 16 minus x squared, 16 minus square root of 7 squared. Square root of 7 is simply 7, so 16 minus 7 is 9. Plug our old upper bound, initial upper bound, in for x. So 16 minus x squared, 16 minus 0 squared is still 16. So after our conversion, our new upper bound in terms of u is 16. Our lower bound in terms of u is 9. Now we're ready to evaluate. Plug the upper bound first. 16 goes in for u, so we get negative 1/3 times 16 to the 3/2 minus negative 1/3. Now we're ready to plug in the lower bound. Plug 9 in for u, 9 to the 3/2. Now 16 to the 3/2, we can simply evaluate this without having to use a calculator, because we can find the square root of 16 first. So this 2 in the denominator represents the square root. So the square root of 16 is simply 4, and then we take 4 raised to the 3rd power. 4 to the 3rd power is simply 64, so that's what we have here. Okay, the 2 negatives cancel out, gives us a positive. Okay, we can evaluate 9 to the 3/2 by treating the square root first. So this 2 represents square roots in the denominator. So square root of 9 is 3, and then take the 3 raised to the 3rd power. 3 cubed is 27. So we can combine this. Negative 64 over 3 plus 27 over 3 reduces to be negative 37 over 3. All right, number 6. Find the indefinite integral of the cube root of cosine of x, sine of x, dx. Okay, we're going to have to go through u substitution, so we want our u value to be what's inside the radical as cosine of x. So the derivative of cosine, du over dx, is simply negative sine of x. We solve for dx, and dx equals du over negative sine of x. Let's make our substitution. So inside the cube root is cosine. Cosine gets replaced with u. So we rewrite it as rational exponent, so u to the 1/3, times sine of x, doesn't cancel out initially, times, and then replace dx in terms of u, in terms of du. So du over negative sine of x. Now we see that the sine of x conveniently cancels out, but we got to be careful. This negative 1 is still going to remain in our problem. Okay. Now we're ready to apply the power rule. So add 1 to this initial exponent. So 1/3 plus 1 is 4/3. So negative u to the 4/3 over 4/3. Flip the reciprocal to bring it up to the top. So we get negative 3/4 u to the 4/3. Okay. We want to replace u in terms of the original value. In this case is cosine of x. So negative 3/4 cosine of x to the 4/3 plus c. All right, number 7, indefinite integral of x times the square root of 1 minus x. We can't just use power rule. We can't distribute the x through. So we look at what's inside the parentheses, inside the radical, and we let that be the u value. So u value is equal to 1 minus x. We find the derivative with respect to x. 1 goes to 0. Negative x becomes negative 1. Cross multiply. Dx equals negative du. We make our initial substitution. X stays. Square root of 1 minus x can be rewritten as square root of u. And then square root of u can be rewritten as u to the 1/2. Dx gets replaced with negative du. So at this point, we see that we still have a x left over. And we have to find a way to get rid of this x so we can continue with the problem. We need all this to be in terms of one variable in terms of u. So we go back to our assigned value for u and look to see if we can rearrange. So if I solve for x, I can solve for x in terms of u. So if I replace x with 1 minus u, which I do here, now I can simply distribute and separate the terms, each term in terms of u, and then go through power rule. So I'm going to distribute negative u to the 1/2. This negative, we have to still include this negative. So negative u to the 1/2 distributed through the parentheses, the 1 minus u. So we're going to get negative u to the 1/2 plus u to the 3/2. Okay, we add exponents when we're combining bases. So 1/2 plus 1 is 3/2. So now we're in position to be able to apply the power rule. So negative u to the 1/2 becomes negative u to the 3/2 over 3/2. U to the 3/2 becomes u to the 5/2 over 5/2. Bring these coefficients. We want to resolve these complex fractions. So flip these fractions. 3/2 becomes negative 2/3, and 5/2 becomes 2/5. And replace u back in terms of x. Don't forget the plus c, since this is an indefinite integral, and we have our solution here. All right. Number 8, find the derivative of the definite integral of 1 minus t squared from negative 4x to square root of x. Okay. So here we can use the adapted second theorem of calculus, which says that I can basically ignore these two operations because I know that the integral and derivative processes are going to cancel each other out. We just have to make some adjustments through the upper and lower bounds. So the rule says we plug the upper bound in for the original variable, so 1 minus square root of x, quantity squared, times upper bound's derivative. So square root of x becomes x to the 1/2. The derivative of x to the 1/2 simply 1/2 x to the negative 1/2. Okay, minus, now we're ready to plug the lower bound in. Negative 4x takes the place of t, so 1 minus negative 4x quantity squared times the lower bound's derivative, so negative 4x becomes negative 4. So now it's just a matter of cleaning up. 1 minus x, because square root of x squared is simply x. The 2x to the negative 1/2 can be pulled down to the denominator as 2 root x. Distribute these two negatives cancel out, so we're distributing the 4 through. So 4 minus 64x squared. Okay, number 9. Given the second derivative being 1 minus 2x, and f prime of negative 1 equals 6, and f of 0 is equal to 14, find the below. Okay, so part A, find the specific equation for f prime. So we're going to take the indefinite integral of f double prime, and then once we're up to f prime, then we can use this ordered pair to solve for c. So f prime is simply the indefinite integral of f double prime. So indefinite integral of 1 minus 2x, we simply apply power rule. So 1 becomes x, negative 2x becomes 2x squared over 2, and then we have plus c. Okay, the 2's cancel out. We get f prime is equal to x minus x squared plus c. Now we use the ordered pair from f prime. So 6 goes in for f prime. Negative 1 goes in for x. 6 equals negative 1 minus 1 squared plus c. This becomes negative 2. So move 2 to the others to the left side. So 6 plus 2 is 8. 8 is equal to c. So we have a specific equation for f prime being x minus x squared plus 8. Okay, part B, find the specific equation for f of x. So we take the integral once again. Integral of x minus x squared plus 8. This is our specific f prime function. So x becomes x squared over 2. We're applying the power rule here. X squared becomes x cubed over 3. 8 becomes 8x. And then we're also going to be producing a constant of integration being plus k. Right. So now we have our general equation. We do have a specific ordered pair that we can plug in. So 14 goes in for f of x. 0 goes in for all the x's. And we're just left with k is equal to 14. So replace k with 14, and we have our specific f of x function. X squared over 2 minus x cubed over 3 plus 8x plus 14.